Hello friends, in this session we will see relative stability in frequency domain. We will also see about omega GC, omega PC, also GM and PM. Let us begin. We have seen that we have basically two types of stabilities. What do I mean to say is we have something called as absolute stability and then we have something called as relative stability. Let me take you through to a small example. Let us take. If I ask you, is Amitabh Bachchan rich? You will say yes, right? Now, if I ask you, is Ambani rich? Yes, he is rich. Which means I am asking you about the absolute stability. I will tell you. See, if I say you Amitabh Bachchan, is he rich? Yes, Amitabh Bachchan is rich. If I ask you whether Ambani is rich, yes, you will say he is also rich, right? Which means when I'm asking you whether the system is stable or unstable, you say yes, it is stable, you say no, it is unstable, which means I'm basically talking about absolute stability, right? Yes. Now, if I ask you how much is Ambani more richer than Amitabh Bachchan, how is Ambani more richer than Amitabh Bachchan? If I ask you the question, then that falls under a category called as relative stability. I'll tell you how. We'll take this example itself. I'll tell you, don't worry. Yes. Let us say Ambani, Mr. Ambani, in his account, example, he has rupees 1000. It is just a simple example, right? Basically, Ambani might have, we just don't know how much he must be having zeros, right? Yes. Anyway, so just for example, I'll take only 1000. Okay. Yes. And now, if I think of Amitabh Bachchan in his bank account, let us say he has rupees 100, right? So by comparing these two, basically Ambani is also rich. Yes. Amitabh Bachchan also rich. Yes. But if you see, Ambani is relatively more financially stable, financially stable than Amitabh Bachchan. Why? Because if you see, if by some means Amitabh Bachchan's income, or we can say his account, let us say, which is having 100 bucks, by some means if this 100 bucks becomes zero, right, and same 100 bucks become zero from Ambani as well, right? 100 bucks becomes zero. So at the end you find that Ambani has 900 rupees still left, right? Whereas if you see Amitabh Bachchan, he has become complete bankrupt. Is that right or wrong? Yes. So if you check out dear, that Ambani has more margin. This is an important term. Ambani has more margin to become poor. Let me take a small example. Same example itself, but a little extension to it. If I say that for any person in the world, if he has bank account balance to be, let us say, rupees 10 or less than 10, then that particular person is characterized as a poor person, as a, right? Now if you check out, if you see, now you will understand this concept, right? See, now if you see Amitabh Bachchan, if Amitabh Bachchan, who is already rich, right? Ambani is also rich, he is also rich, both are rich. Now if you see, if Amitabh Bachchan has to become poor, then he has margin of how many rupees? Then that will be 100 minus 10, which is 90 rupees. Means if by chance accidentally if Amitabh Bachchan loses 90 rupees, then he will become poor. Is that right? Yes. But now if we think of Mr. Ambani, if we think of Ambani, if Ambani has to become poor person, then he has a margin of, if you see, 1000 minus 10, right? Which means he has 990 extra. He has 990 rupees extra. Am I right? Which means Ambani has more margin as compared to Mr. Amitabh Bachchan, right? Because if you see, if Amitabh loses 90 rupees, he will become poor. But if the same 90 rupees, if Ambani loses, then still he will be rich. Getting my point, right? So if you see, relatively Ambani has more stability margin than that of Amitabh Bachchan. Are you understanding my point? This is a very easy and very important thing, concept. Okay, right? Yes. Now on the similar lines, if I think of our plots, our frequency domain analysis, let us think of that, right? Let us say this is our GH plane, so this becomes real part of GH and this becomes imaginary part of GH, right? Yes. Now let us say I have a polar plot. What plot? Polar plot, right? Let me have a polar plot which starts like this and it comes here. Okay, what I will do is, let me just mark -1 point here. Okay, let me have one more polar plot like this which comes here. So let me call this one as 1 and let me call this one as second plot, right? Now let me have third one which goes exactly through the center, which is the third one. And if I think of the fourth one is this. Let me take another color, or it's okay, no problem. Let me just keep it 4 only, right? Yes. Now if you see, what do you have? What do you have? If you see, basically you know that this is a polar plot, right? If you are supposed to have the Nyquist plot for the same, what will happen? You will first take the inverse polar plot, right? And then you will take the semicircles, right? So for the first case, if you see, for the first plot, if you see, even if you draw a Nyquist plot like this, then also there will be no encirclements around -1, right? Similarly, if you think of second one also, if you try to draw the inverse polar plot for second one, even now you will not have any encirclements. Even for the third one, if you see, if you try to draw the inverse polar plot, it will go like this, which means still there will be no encirclements, which means first, second, third are stable, right? But if you think of fourth one, then yes, for fourth one, if you try to draw the inverse polar plot and then a semicircle like this, right? Then if you see, yes, the fourth one which is there, it will encircle this -1, encircle this -1. What does that mean? What does that mean? We need to understand. If you check out the Nyquist plot for 1, 2 and 3, if you see, it will never encircle -1, right? So we can say that they are stable, right? Yes. But if you check the distance, if you observe this distance from 1 and this 1, and if you observe this distance, what do you find out? Between this 1 and this 2, if you see, this 1 is quite far from -1, right? And if you see this 2 which is there, second plot, it is quite closer to -1, So this means that it is that 1 is relatively more stable than 2. Is that right? Yes. So we have tried to understand this with respect to gain. Means if you think of yes, if you see here, if this is -1, right, this is -1. If you check out here with respect to gain, there is a margin of 0.4. I mean to say if you want to make this particular system, this system which is shown here, if you want to make this system critically stable, then you have to add magnitude of 0.4 such that this minus 0.6 will get shifted to -1 like this, and it will become marginally stable, right? Which means you still have some margin of 0.4. Getting my point? Yes. Now I will talk about angles. Now let us think of angles. Yes. So if you see here, dear, that if you try to find the plot, I mean to say, see, these are nothing but the polar plots, right? Yes. Now if I try to take the inverse of this, let us say, then where will be the encirclements? There will not be any encirclements, right? For the second one also, if I try to find the inverse polar plot, this will be somewhere like this. Is that right? Yes. Similarly, for the third one, if you see, it is going to be somewhere like this. Then for the fourth one, if you see, it is going to become like this. Getting my point? Now if you think about this tail of 1 is quite far than 2, is quite far than 3, and it is quite far than -1. I mean to say that from -1 angle, if this is minus 180 degrees, right? Yes, from this angle, this minus 180 degrees, if you check out, or let me just do one thing. Let me draw a circle with radius as 1. Let us say this is -1 and the radius goes like this. This is the circle, right? Yeah, this is the circle of, let me write down, yes, radius equal to 1, unity radius circle. Okay, so if you see, everywhere the magnitude is 1, right? Magnitude is 1 here, also magnitude is 1 here, also magnitude is 1, right? Here also magnitude is 1, everywhere it is 1. Okay, here also magnitude is 1. Now if you think of angle, this angle, this angle, this angle, and this angle, if you see, angle for the first one is quite far, then second, then third, which means that one is more relatively stable than 3, because if you see, encirclement is happening where when this minus 180 degrees has been crossed, which means this particular one, right? This is where encirclement has happened, right? So if you check out 1 is relatively more stable than 2, and it is again relatively more stable than 3, because this angle difference is more, this angle difference, because to make this angle difference, this is theta, if I say, then this theta is more here, theta is far more here again. I hope you are understanding the point, right? Yes. Now I will try to make few observations. What does these two plots tell you? These two plots tell you that when angle of the polar plot, let me consider another color, it tells you that when angle of the polar plot is minus 180 degrees, mind my words, okay? When angle of the polar plot is minus 180 degrees, then the gain should be less than -1. If you see here gain is -1, here the gain is minus 0.6, which means the gain is lesser than 1. So in terms of gain, if you see, I have to ensure that when my angle is 180 degrees, when I am on the same angle, when my angle is 180 degrees, sorry, when my angle is minus 180 degrees, then at that time What should I ensure? I should ensure that my plot gain when angle is minus 180 degrees has to be lesser than minus 1, has to be lesser than minus 1. This is what we have understood. Now from the angle 1, if you see what is that when the gain of my polar plot is 1, I mean this one, this circle, right, which we drew this circle. When gain of my plot is 1, the angle should be greater than minus 180 degrees. What does this mean? I will tell you. If you observe, this is minus 90 degrees, right? Now you agree with me that this is stable and this is stable, whereas this one is unstable, if you see. So if you see here, what will be the angle here? Let us consider that, let us say this angle is 110 degrees, this angle is 130 degrees, let us say this angle is 150 degrees, minus 130 minus 150 minus 110, right? So I said that the angle should be greater than minus 180 degrees. So you please tell me, between minus 150 degrees and minus 180 degrees, minus 150 degrees is definitely greater. This is 10th standard thing, mathematics, right? So that is what I said. I said that, again I am saying the same thing. If you just observe it for here, let me say that this angle, let us say minus 210 degrees, because this is minus 270 degrees, right? So definitely whatever angle has to come between this minus 180 degrees and 270 degrees has to be equal to somewhere around the same between them values, right? So again, if you check here, minus 210 degrees, 210 degrees, it is what? Lesser than minus 180 degrees. So this is not sureable, or this should not happen, because if this thing happens, then yes, definitely system will become unstable. How it will become unstable? Because you will have some encirclements. I am not saying that it will be, but I am saying that it may be unstable, right? Yes. So if you check out from the angle perspective, this is the complete thing, right? That the angle when my gain of the polar plot is minus 1, then the angle should be greater than minus 180 degrees. Angle has to be greater than minus 180 degrees, then only it is going to be stable. Similarly, if you see here, when my angle is minus 180 degrees, then my gain which is there, gain which is there, it should be less than minus 1. It should be less than minus 1. We have seen that. Now I will try to write all these things in terms of few equations or few expressions, to be specific, right? So the first term we have is gain crossover frequency. What is that? It is shown by omega gc. What is that frequency? I will tell you. See, it is the frequency at which magnitude of loop gain gh becomes equal to 1. What do I mean? See, this is magnitude of gh, right? Yes. At omega equal to omega gc, my magnitude of gh will become 1. So that particular frequency is called as omega gc. This is nothing but the frequency, right? Now the next thing which we understood is phase crossover frequency. How is that shown? That is nothing but omega pc. Okay, yes. Now if you check out the frequency at which angle of the loop gain gh becomes equal to minus 180 degrees, you will not appreciate that, I know. So for that, let us say angle of gh which is there, the frequency at which means omega equal to omega pc. At this frequency, what has to happen? My angle should be equal to minus 180 degrees. So this is the formula. From this formula you will get omega gc. From this one you will get omega pc, right? Now the third one is gain margin. What is that gain margin? Shown by gm. Gain margin is the gain of gh when omega equal to omega pc. I mean to say, now if you see this gain and all, no, everything we take in terms of decibel. So in order to show that, what we write is that gm, the formula for that becomes gm equal to minus 20 log to the base 10 mod of GH at omega equal to omega PC. This is the formula for GM. This is the formula for GM, gain margin. Getting my point, right? Yes. Now, if you think of phase margin, what is phase margin? We have seen just now, we saw the stability things. See here. If you see between minus 180 degrees, let me consider this one minus 150 degrees. Then you say that you still have margin of 30 degrees, right? I mean to say, if I even more, if I give 30 degrees to this one, then also it will become minus 180 degrees. Getting my point? So this is the margin. This is what we are talking about. Similarly, this 0.4 which is there, this is nothing but the gain margin. This is nothing but the gain margin. That's it. That's it. Keep things simple, right? What is that? Because when your angle is minus 180 degrees, at that time, what is your actual plot? Your actual plot is here. Now, in order to make this actual plot to be critically stable, you have a margin of some margin that is given by gain margin, GM. Similarly, in order to make your plot, critically stable, how much more angle you have, how much more angle you can add, that is nothing but the phase margin, right? So phase margin, if you see the formula, what is that formula? That formula is nothing but 180 degrees plus angle of GH at omega equal to omega GC. Getting my point? At omega GC. Now I will take some examples such that it will be very useful for you, right? You will understand it, the interpretation part. Let us take some examples for that. Let me take the first example. Yes, so if we check out for this one, the polar plot somehow looks like this, right? We have already solved this type of question. So this is the real part of GH, this is the imaginary part of GH. How it looks is like this. This is the polar plot, right? Step 2 was what? Step 2 was this one, inverse polar plot. And yes, if you see, there are no poles or zeros at origin, which means there will be no semicircles. We have seen that. Okay, yes. Now, and if you observe now, do you think that definitely minus 1 will be here or not? Yes, minus 1 has to be here. So are there any encirclements for this? No. So if you check out, n is equal to OLP plus minus CLP plus, right? OLP plus, are there any poles on the right half of S plane? No, which means this is 0. Encirclements are also 0. So closed loop poles at RH is also 0, which means it is a stable system. Now, this is what we have seen till now. Now, let us appreciate the things which we have studied just now. What are those things? GM and PM. How to identify them? If you see, if you want GM and PM, right? So you need to understand what is omega GC, where is omega GC, and where is omega PC. So let me start with omega GC. Okay, so omega GC is what? Omega GC is this one, right? You just find the magnitude of GH, put omega equal to omega GC, equate it to 1. Omega GC, you will get from there, right? So omega GC is the frequency at which the gain is equal to 1. So omega GC, which is there, let me take it as 1 by, if you think of, this becomes under root of omega squared plus 1, right? Similarly, under root of magnitude of this one becomes 2s plus 1 is there, so it means it becomes 2 times j omega plus 1, which means it is nothing but 2 squared omega squared plus 1, which is 4 omega squared plus 1, right? Yes, this is your omega gc, right? To find omega gc, you do this. So at omega equal to omega gc, which is equal to 1, which is equal to 1. So if you think of omega equal to omega gc, if you just replace, or if you try to find out, then how much do you get? If you just do squaring on both sides and you inverse it, squaring on both sides and inverse, then you get omega squared plus 1 into 4 times omega squared plus 1 equal to 1. Therefore, you get 4 times omega to the power 4 plus 5 times omega squared equal to 0, which means 4 omega squared plus 5 equal to 0. That means omega is nothing but equal to under root of minus 5 by 4, right? Which is nothing but omega gc only. So if you think of, if you think of this is omega gc. Now, if you see this value, this actually becomes j plus j under root of 5 by 4, right? Yes. So if you see, is this frequency real? No, this frequency is imaginary. This frequency is imaginary. What does this mean? This means that there is no real frequency at which the plot ever crosses -1. The same can be observed in the Nyquist plot as well, right? There is no frequency for which this -1 has been crossed. This -1 was never crossed. This -1 was never crossed. That is the reason you have no frequency for which your gain is equal to 1, which means omega gc not applicable, which means when omega gc is imaginary. What does this mean? What does this mean? Gain margin is what? Gain margin is infinity. What do you mean by infinity? You can add as much of gain you want, the system will not become unstable. Getting my point? You add as much as gain you want, the system will not become unstable. Why? Because you don't have omega gc only. The omega gc which is there, it is imaginary, which means there is no real omega gc, which means gm is infinite. You can add any gain to the system will not become unstable. Getting my point? Similar case with omega pc also. Omega pc will also be imaginary if you check that out. And yes, the pm will again be infinity, which means again you can add as much of gain you want and you can add as much of phase you want, but the system will always remain stable irrespective of the gain and the phase you put in the system. Getting my point? Yes, it was very simple. Now second example will be important, more important. See, yes, here if you see, you have got 1 upon s into s plus 1 into s plus 2, right? Which means the plot for this, we have seen such examples, the plot for this will be somehow like this, right? Somehow like this. What will you do? We are not interested into this. We are not interested into this. What are we interested into? We are interested in trying to interpret the stability in terms of GM and PM, gain margin and phase margin. So let me calculate omega GC first and then omega PC and then try to find the GM and PM. Okay. Yes. So for omega GC, what is the formula to get omega GC? You please take magnitude. If you see, what will be that magnitude? If I place the GH of J omega, this will be equal to 1 upon J omega into J omega plus 1 into J omega plus 2. This is the function, right? So this magnitude will be omega, this magnitude will be under root of 1 plus omega squared, and this magnitude will be under root of 4 plus omega squared. So you get omega into under root of omega squared plus 1 into omega squared plus 4. Is that correct? Yes, this is equal to 1, and at omega equal to omega gc, will I get this equal to 1? Let us see. Let us see. This has to be equal to 1. If I equate, what do I get? What do I get? Let us see. So again, by squaring and by inversing, squaring on both sides and take inverse, what happens then? You get omega squared into omega squared plus 1 into omega squared plus 4, right? Which is equal to 1. Because if you square, this omega will become omega squared and this under root will go, and this one will be 1 only, and then if you inverse you get this 1 by 1 to be equal to 1 itself, right? And then if you inverse this you get this way. Now what do you get then? If you solve this you get omega squared into omega to the power 4 plus 5 omega squared plus 4, this which is equal to 1, and then you get omega to the power 6 plus 5 omega to the power 4 plus 4 times omega squared minus 1 equal to 0. If you place this in calculator, this is the cubic equation, right? You get omega squared equal to 0.1986, which means omega equal to under root of 0.1986. Therefore you get omega gc to be equal to 0.4456 radians per second. Is this the real frequency? Yes. Which means the plot has gain of 1 at some point. Yes. And it can be seen also, right, that this plot definitely has gain to be equal to 1. That can be evident also, right? Now if you think of omega pc, right, what we do for that, we take angle omega pc, right? To find omega pc you take angle of gh at omega equal to omega pc, which is equal to, how much is the angle? See, angle contribution because of the j omega will be minus 90 degrees. On top it goes, it becomes minus 90 degrees. Then this one will become minus tan inverse of imaginary part upon real part, which is equal to minus tan inverse of 1 of omega by 1. So it becomes minus tan inverse of omega by 1 minus, again you get this one to be tan inverse of omega by 2 minus tan inverse of omega by 2. Is that correct? Now what am I supposed to do? I am supposed to equate it to minus 180 degrees, right? So if I equate it to minus 180 degrees, what do I get? If I combine these two, what do I get? Then I get minus 90 degrees minus tan inverse of, if you think of, this is a and this is b, what is there? A into b, this is 1 and this is 0.5, so it is going to be 1 into 0.5, sorry, 1 plus 0.5. What is 1 plus 0.5? It is going to be 3 by 2, right? So this becomes 3 omega by 2 upon 1 minus a into b. A is omega, b is omega by 2, it becomes omega squared by 2, right? And this has to be equated to minus 180 degrees, we have seen. See, where is that? Yes, minus 180 degrees, it has to be equated. So if you solve this you get 1 minus omega squared by 2, which is equal to 0. Therefore you get omega, which is nothing but omega pc, to be equal to root 2 radians per second, which is nothing but equal to 1.414 radians per second. Getting my point? Yes. Now I am interested in finding gain margin and phase margin, right? What is gain margin? Gain margin is equal to mod of gh at omega equal to omega pc, which is nothing but equal to root 2, right? And minus 20 log of this one, so it is basically minus 20 log of gh at omega equal to omega pc, which is equal to under root 2, right? So if I think of, I have this minus 20 log already, right? This is gain margin in dB, definitely, yes. So let us find the magnitude at omega equal to omega pc. So it becomes 1 upon omega into under root of omega squared plus 1 into omega squared plus 4. Is that right? Yes. At omega equal to omega pc, which is equal to root 2. So if I replace root 2 in place of omega here, what do I get is I get minus 20 log of 1 by, if you think of, root 2 into under root of root 2 squared becomes 2 plus 1 into again root 2 squared becomes 2 plus 4, right? So this comes out to be 1 by 6, so it becomes minus 20 log of 1 by 6, right? Which is equal to how much? 15.56 dB. I will tell you the interpretation after this, don't worry. Let me now calculate PM. If I calculate PM, what do I get is, PM is what? Basically 180 degrees plus angle of GH at omega equal to omega GC. Very simple formula, right? What is omega GC? You have got 0.4456. Is that right? Yes. So this is equal to what? 180 degrees plus minus 90 degrees minus tan inverse of 3 omega by 2 upon 1 minus omega squared by 2. This is what we have seen. Where is that gone? We have seen that from here. This is the angle, right? Yes. So now if you replace this omega by 0.4456, what do you get is 180 degrees plus minus 90 degrees minus, if you replace this omega by this one, by this 0.4456, you get, and this particular omega also by this one, then at the end you get, after calculating, you get 36.578 degrees, okay, which is equal to 180 degrees minus 126.578 degrees, which means PM is equal to what? PM is equal to 53.422 degrees. Getting my point? Yes. Now I want to tell you one very very important thing related to GM and PM. Please concentrate. If you see, GM and PM both are positive, both are positive. Please note, whenever GM and PM both are positive, this means system is stable. I will tell you the interpretation just now. What does this gain margin means? It means that 15.56 dB you have. It means that I can add 15.56 dB more gain to make the system critically stable. Means this system is already stable. Yes, if I want to make this system critically stable, or if by chance the system has to become critically stable, then it has a margin of 15.56 dB. Getting my point? Yes. Similarly, if you think of phase margin, if I want to make this stable system as a critically stable system, then I have to add a phase margin of 53.422 degrees. Getting my point? And the last conclusion which you got, this is note, very very important note, that when GM and PM both are positive, the system is stable. The system is stable. If any one of them is negative, it means system is unstable. It means system is unstable. Getting my point? I will tell you this example. See, if for example you say that GM is negative, if you see here, if I take this point as -1, and now if I have some plot like this, right, and let us say this is at, let us say -2, this is -1. So I know that for this particular plot, definitely there will be encirclement like this, which means it can become unstable, right? Now if you see, this is -2, this is -1, right? This is -2, this is -1. Now if you check what is the, what do you say, margin difference, if you see, there is no margin difference. Why? Because this system is already unstable. This system is already unstable. Already you have this encirclement. So even if you try to find out for this one, what you get will be -1. See, -2, minus of -1. This difference, if you want to check out this magnitude difference, also you may interested in, the magnitude difference will be definitely 1 magnitude, but the with sign it is going to be -1. Why? Because with respect to -1, you are supposed to check this, right? And we had seen that we have to ensure, whenever your angle is -180 degrees, you have to ensure that your gain is less than -1. Your gain is less than -1. But if you see here, the gain is nothing but 2. Here the gain is equal to 2, which is greater than 1, which means it is unstable. That is what we have understood. So in this particular way, we have seen the importance of gain margin and phase margin. What is the concept of relative stability, right? And we have also seen that when GM and PM both are positive, we say that the system is stable. If any one of them is negative, it means that system is unstable. This is what we have learned, right? Thank you.